All right, guys, April 23rd, this is section 5.4. We're getting close to being done with chapter 5 here. So today we're going to talk about properties of logarithms and how to utilize those. We've already introduced logs and graphed them a little bit. Some of these are pretty straightforward though. Log base b of b. Think about our definition of logarithms here. B to the first power equals b. Well, that makes sense. B to the 0 power, well, anything to the 0 power is 1. B to the x should be b to the x. And log, or b raised to the log base b of x. These are inverses of each other, logs in exponential. So if you take b to a logarithm or a log of b to something, they're going to cancel each other out, basically. Okay, so those are ones we have to remember as we go. So solve each equation by applying fundamental properties, answer an exact form, an approximate form using a calculator. All right, so what I tend to do, if I can, is just utilize the definition of a logarithm here. ln is log base e, and so this is equivalent to e to the second equals x. So that would be the exact version, you guys. And then, of course, approximate, take e to the second, round to thousandths, so which is about 7.389. Okay? The second one, log, if it's not given a base, is base 10. That's the common log. So this would be 10 to the negative 0.52 equals x. And again, on the calculator, to the thousandth, that's going to be about 0.302. Okay, so the first couple ones, not so bad, right? You guys got this. Same directions, you guys. Solve each equation by applying fundamental properties. So I have to get rid of an e. Well, remember that exponentials and logarithms are inverses of each other. So if I take the natural log of both sides, because that's log base e, the natural log of e to the x would eliminate that e to the x and give you that. So this is just going to be the ln of 167. Okay? And so on the calculator, ln 167, that is about 5.118. Okay? Well, in the second one, instead of taking the natural log of both sides, which we did that on this one because it was base e, this is base 10, which is the common log. So if I take the common log of 10 to the x, I'm left with x, because the 10 would cancel, common log of 10 to some power. And then on this side, I would have log of 8.223. Okay, so then I hit the common log button and type in 8.223. And get 0.915. Again, pretty straightforward. As long as you recognize that logs and exponents are inverses of each other, we can just cancel them out. Right? Solve each equation, right? Answers in exact form and approximate form. So what we want to do here is we want to get the exponents by themselves so that I can use logs to undo them. So I've got a little bit of algebra to do first. Okay, so step one on this one, I'm going to add 29 to both sides, and I'm going to have 10 to the x equals 80. Okay, and then how do I undo 10 to a power? Well, I take the common log of both sides. The common log of 10 to the x is just x, and on this side I've got log of 80. So that's your exact answer, okay? The approximate to 4 decimal places, log of 80, 1.9031, okay? The second problem, let's get that e by itself. So I'm going to add 5, 3e to the x plus 1 equals 12. Okay, divide by 3, e to the x plus 1 equals 4. Now I have to get rid of the exponents, so I'm going to take the natural log of both sides because I have base e. So the natural log of the left side is just going to be x plus 1. The right side is going to be ln of 4. And then I'm going to subtract 1. So x is going to be ln of 4 minus 1. And again, on the calculator, that's about 0.386 Okay, so isolate the exponent and then take the log of both sides to get rid of it. Okay, similar situation, except now I'm going to isolate the logarithm and use exponents to get rid of it. Okay, so let's start by subtracting 1. 2 log of 7x, subtract 1 equals 3. Okay, I'm going to divide by 2, so log 7x equals 3/2. Now I've got the log by itself. The base on this log is 10, so I'm going to go 10 to this power. 10 to the 3/2 power equals 7x. And if I want to get x by itself, I then have to divide by 7. So x is going to be 10 to the 3/2 over 7. They want this to 4 decimal places again, so let's see what we get. 10 to the 3/2 power divided by 7. 4.5175. Second example. Let's get this log by itself. So I'm going to add 5. I'm going to divide by -4. And now I've got the log by itself, so I'm going to rewrite. This is base e, so e to the -3 equals x plus 1. And then subtract 1. E to the -3 minus 1 equals x. Let's see what we get on the calculator here. So e to the -3 minus 1, I get about -0.9502. Okay? So a little bit of algebra. Isolate the logarithm, rewrite it as an exponential. Okay? All right, properties of logarithms. We're going to use these quite a bit, expand and contract functions based upon what we have here. So if I take log base b of the product of two things, I could break that up into the sum of two separate logarithms. So I could go log base b of m plus log base b of n. Okay? Quotient, if I have m divided by n, I can change that addition to a subtraction. So this is log base b of m minus log base b of n. And if you have a power, m to the p, the power can come out in front, p times the log base b of m. So we're going to utilize those to rewrite some logarithmic properties. So use the properties of logarithms to rewrite. Okay, these are both log 2, so I can use that property. And there's an addition in between. So that means I could have went log base 2 of the product of those, of 7 times 5, which is log base 2 of 35. That's equivalent. Okay? The second one, I see an addition, so I'm going to multiply. So I got ln. That number out in front becomes a power, so that's going to be x squared times x plus 6. So I can simplify that just by distributing. So x squared times x is x to the third. X squared times 6 is plus 6x. Okay? Now I see a subtraction, so that meant division for us. So they both are common log. Okay? X plus 2 divided by x. Subtraction turned into division. Okay? Let's bump ahead to example 6 here. Okay, use the power property to rewrite. So if you see a power, you pull it out in front. So for this first one, that's just x ln of 5. Okay? For the second one, that x plus 2 is a power, so I'm going to have x plus 2 log of 32. Okay? And the third one here, I don't see an exponent initially, but if you thought of this one as the log of x to the 1/2 power, because the square root is the same as a 1/2 power, then I do have an exponent, and I can bring that out front. 1/2 log of x, like so. Okay? So be careful with those radicals, and remember they can be written as exponential powers. Okay? Use the properties of logarithms to write them as sum or differences. So now we're going to expand them. Okay? So x squared I see a power on that, so that power can come out front. 2 log of x. And multiplication here, the product property turns into addition over here, plus log of z. Okay? The second one here, again, that's all to the 1/2 power, so the 1/2 is going to come out in front. Okay? Then I've got a log of x, and division, quotient turns into subtraction, minus log of x plus 5. And I guess I could distribute that 1/2, so I could go 1/2 log of x minus 1/2 log of x plus 5, like so. So just getting familiar with those properties, guys, okay? All right, change of base formula. This is kind of an outdated formula, to be real honest with you. It's a way to, take log base 2 of something, because we've been up until now dealing with log base e, natural log, or common log, log base 10. What if I had log base 2 of something? How could I rewrite it using the natural log or the common log? That's what this property is. I'll show you an example of how to do it, but I'll also show you how to do it on your calculator, okay? So find the value of each expression using the change of base formula, answer an exact form and approximate form using 9 digits, then verify the result using the original base. Note that either base 10 or base e may be used. So change of base for this is pretty straightforward, you guys. This is going to be ln of 29 over ln of 3. That's all we have to do, okay? And so we can, obviously you could do that on the calculator. Ln of 29 divided by ln of 3, 9 digits, okay? You can bring that out to 9 digits if you want, but 3.065, 044, 75. Well, we'll go all the way up, 752. Okay, now, here's the other thing you could do on your calculator, and I'm fine with this, guys. If you go into math, and you go down towards the bottom, it says log base, and you're able to write log base 3 of 29, just the way it's written here. And as you would expect, you get the same result, okay? The second problem, change your base, would be log of 3.6. Again, I could use the common log, but ln is less letters, so that's why I picked that one, to be honest with you. Over the ln of 5, okay? So again, ln 3.6 divided by ln of 5. So that's 0.795, 888, 947. Again, if I went math and I went down to log base, I could do log base 5 of 3.6, and I get exactly the same thing. So that's all that change of base formula does, you guys. Either way is fine. Okay, the log base in the calculator is just fine with me. And then we've got a couple examples here. I'm going to write this formula off to the side. The pH level is the concentration of hydrogen ions. So the formula for that is negative log of the positive hydrogen ions concentration, okay? And so they're going to either give me this or they're going to give me pH, and I got to solve for one or the other, okay? So ocean water has a pH near 7.9. What is the concentration in hydrogen ions? Write it in scientific notation. Okay, so initially I know the pH is 7.9. That's supposed to be negative log of the positive hydrogen ion concentration. Okay, so I'm going to divide by that negative, so I get negative 7.9, because I'm trying to get this logarithm by itself. Okay, and now I'm going to rewrite as an exponential because I've got the log by itself. So 10 to the negative 7.9 power equals h plus. Okay, so of course you can type in here 10 to the negative 7.9 power. And the calculator is going to give it to you in scientific notation, okay? So that's going to be 1.26, let's say, times 10 to the negative 8, right on your calculator screen. So that's all you have to do to solve a problem like that. We'll do one more example where I give you the other part, and then I think we'll be ready to go. So The concentration of hydrogen ions in an everyday apple is near 7.94 times 10 to the negative 4. What's the pH? So pH equals negative log of 7.94 times 10 to the negative 4. Okay? Quite honestly, you guys, this one's easier because the variable's on the left side. So I just need to type in negative log, and I can use scientific notation. So I'm going to do 7.94. Above your comma is an EE button, and it's engineering form, but it means times 10 to this. So I'm going to go E and then negative 4. So times 10 to the negative 4th. Or you can just write it in exactly the way you see it there. Either way, I get the pH of that apple to be 3.1. Okay? All right. I've got the assignment here, but one thing you'll notice, please pay attention to classroom. I've made these assignments smaller. This is going to be every other odd, and so be careful that it's going to say every other odd in the homework. And so don't do more than you have to do. All right. See you guys.